Alright, this is the intermediate 4 lesson, exponents, squares, cubes, and roots, and you're going to have a lot of writing to do. So exponents. Exponents is a shorthand for multiplying the same number times itself. So for example, 4 times 4 times 4 times 4, let's throw another one in there, times 4 is 4 to the 5th. The big 4 here is called the base. The tiny 5, which is superscript, is the exponent. Once again, it's a shorthand for multiplying the same number by itself. Should also be mentioned that if you have a number like 5, it is implied that the exponent is a 1, because this is one of those 5s. If you have a variable like x, it's implied that the exponent is a 1. Squares. Squares is what it sounds like. It is a square. So if you have something like 3 squared, it means you have a square that's 3 by 3. If you have a square that's 4 by 4, that is 4 squared. How many squares are inside there? Well, there's 16. 4 squared is 16. 4 times 4. Cubes, also what it sounds like. It's a rectangular prism in which each dimension is the same length. So if each of these dimensions are 1, this is 1 cubed, which is 1. There's 1 cube inside there. If each of these dimensions were 8, that's 8 cubed, which is a huge number. Put that in my calculator. It's 512. Probably should know that. I don't. That means if this is 8 by 8 by 8, that across the bottom here we could fit 8 cubes. All the way across the bottom we could fit 64. It's 8 times 8. And then we can stack them 8 high. That would give us 512. Properties of integer exponents. So there's a lot of information that's involved in this. Let me tell you what these properties are. One property is that if you multiply two numbers with the same base, figure out what the answer to that is, you add the exponents. Example with numbers, well, with the kind of numbers, let's say that we had x to the 5th times x squared. That would be the same as x to the 7th. Add the exponents. Second property, and these properties are in no special order, if you have a base raised to an exponent, which in turn is raised to an exponent, you multiply those exponents. Example, let's say that we have 3 squared to the 5th. That's going to be 3 to the 10th, because 2 times 5 is 10. If you have a product, two things you're multiplying, and that is raised to an exponent, that means you can simply use that exponent for each of the factors that you're multiplying together. So if we had something like 2 times x to the 4th, that would be 2 to the 4th times x to the 4th. Fourth one is the quotient property. Quotient means divide. If you're dividing two things and that's raised to an exponent, you can apply the exponent to both the numerator and denominator. Example, if we have 3 halves to the 5th, that's going to be 3 to the 5th over 2 to the 5th. Finally, any number raised to the 0 power is 1, as long as that any number isn't 0. 0 to the 0 power is undefined. Any other number to the 0 power is going to be a 1. All right, let's look at an example. If x and y are real numbers, which one of the following is equivalent to x to the 4th x cubed minus x to the 4th x cubed? So I'm just going to write this down. X to the 4th times x cubed, that is the product property, which says you add the exponents, that's x to the 7th. X to the 4th cubed, that's a power to a power, you multiply the exponents, that's x to the 12th. Now, can we combine these two terms together? You can only combine them when they are like terms. These are not like terms. To be like terms, you need the same base, which they do have the same base. You need the same exponent. They are different exponents. So this is as simple as this can get. It is x to the 7th minus x to the 12th. Just to remind you what like terms is, if this was 7x minus 12x, you can combine those because they have the same base of an x and the same exponent as a 1. This would be negative 5x. Another example. Actually, no, let's talk about roots. Excuse me, I'm going to sneeze. Oh, forgive me. A root means trying to figure out what number times itself gives you an answer to something. So for example, let's say we wanted to find the square root of 81. If there's no number written in this little spot here, it means there's a 2. So square root of 81 means the same thing as square root of 81. What number times itself is 81? Well, the answer is 9. You could do, what's the square root of 4? That's 2. What's the square root of 25? That's 5. In addition to square roots, you can have other types of roots. You can have cubed root. What number times itself 3 times is 27? That's what that question is asking. The answer is 3. 3 times 3 is 9, times 3 more is 27. What's the cubed root of 125? So what number times itself again is 125, and the answer is 5. You can have all different kinds of roots. Mainly on the ACT, it's going to be square roots. Sometimes it's going to be cubed root. So just to remind you that radical and root means the same thing. Here's some roots that you should memorize. Not for the ACT, but just to be a human being alive on planet Earth. Square root of 1, square root of 4, square root of 9, square root of 16, square root of 5, pardon me, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. You should know all those by memory. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Write those down and memorize those as soon as possible. Okay, example, what is the cubed root of 8? What number times itself again, gives you 8? The answer is 2. 2 times 2 is 4, times 2 is 8. Number 2, I don't have the square root of 468 memorized. It's possible that this is not an integer, that it's a decimal. If you look at the answers, there are no decimals. So that means we need to break this down into its prime factors and figure out what this is. So we make a factor shrub, factor bush, if you will. 468 breaks down to 4 times 117. 4 breaks down to 2 times 2. 117 breaks down to 9 and 13. Two's prime, 2's prime, 9 breaks down to 3 times 3, and 13 is prime. Once you have all prime numbers, and you're trying to figure out what this simplifies to, you circle pairs of the same number. The reason it's pairs, this is a square root. If this was asking for a fourth root, you would need a group of 4 of the same number. So we have a pair of 2's, we have a pair of 3's. For every pair, you put one number on the outside of the radical. So we have a 2 and we have a 3. Anything that is uncircled stays on the inside of the radical. That's 13. 2 times 3 is 6. So when you get to the end, any numbers that you have on the outside, you multiply together. Any numbers left on the inside, you multiply together. So you end up with 6 square roots of 13, which is this right here. A quicker way to do this problem, much quicker, is to type into your calculator square root of 468. Hit enter. It's going to give you a number. It's going to give you 21.6 approximately. Then take all these other numbers and put them in your calculator. This is obviously not 21.6. This one here is close. Square root of 13 is less than 13. So you're really only down to 3 choices, but 6 square root of 13 will check out and give you the same answer. Alright, that's page 1. Rational exponents. These are exponents that are fractions using integers. So there's one really important property, and it's probably, I guess, the only one that we're going to discuss, and that is the square root, the nth root of x to the mth power, which is equivalent to saying the nth root of x to the mth. The difference between these two, this first one here is saying take x to the m first, then when you're finished, nth root it. The one on the right is saying take the nth root of x, then when you're finished, raise it to the mth power. So the order of operations is different because you get the same answer every time. Both of those things mean the base of x raised to the fraction m divided by n. M was the exponent and n was the root. That is a property that is going to be used frequently. Example, square root of x. If there's no exponent, it's implied it's a 1. If there's nothing inside the little radical symbol, it's implied that it's a 2. So that's x to the 1/2. If you had something like the cubed root of x and you wanted to write it using rational exponents, it's going to be x to the 1/3. 1 is implied as the exponent. Also, another thing that's important, it's not really a property, but it's a fact. If you multiply a radical times itself, a square root radical that is, that's always just going to be the number. And that's because square root of x times the square root of x, when you multiply two things that are the same square root in this case, you put them inside the same radical. X times x is x squared. What is the square root of x squared? What number times itself gives you x squared? Well, it's going to be x. So here's a rule that you want to know. If you multiply a radical, a square root by itself, you always get whatever number is on the inside. Okay, example 1. What's the square root of 2 times the square root of 2? It's 2, for the reason that I just gave up above. Another reason that you could look at it as, you can write this as the square root of 2 times 2, which is the square root of 4. What number times itself is 4? That's the number 2. Number 2, what's the square root of 125? 125 does not have a perfect root. It's not an integer. So if we break 125 into prime numbers, think about quarters. $1.25, that's 5 quarters. And then 25 breaks down to 5 and 5. Got a pair of 5s, put 1 5 on the outside. Anything uncircled stays on the inside, so it's 5 square roots of 5. Once again, if that's too much for you, to put it into your calculator. Square root of 125 in your calculator, hit enter, write down the decimal, and then check each of these answers to see which one of those gives you the same decimal. You'll find that C does. Number 3, when you're square rooting a fraction, you square root the top and you square root the bottom. Square root of 4 is 2. Square root of 9 is 3. So the answer is 2 turds. I didn't misspeak. I said turds. You heard me. Number 4, we are multiplying 2 square roots. We know it's squared because there's no number inside the little radical symbol. You can multiply the numbers together and the letters together. So that's square root of 16 times m squared times n to the 4th. Well, the square root of 16 is 4. Square root of m squared. What letter times itself gives you m squared? It's m. The square root of n to the 4th. What letter times itself gives you n to the 4th? Well, that's n squared. So we got 4mn squared, which is answer B. We are cooking now. And you know what? I think I skipped lots of things I probably should have done. Over here, where we have these properties of rational exponents, no, that's not true. Properties, I did skip some things here. Let's squeeze this in above scientific notation. This is properties of radicals. One is if you are multiplying the same square root times itself, it's just going to be whatever's inside of it. 2, if you're taking the square root of a fraction, you can just square root the top and square root the bottom. 3, which we've already discussed, if you have the mth root of x to the n, that is equivalent to x to the n over m. 4, let's see here. So 1 second. That's good enough. I think those are suffice for us. All right, let's look at scientific notation. Scientific notation is a shorthand and I'm able to write large numbers. So here's how it works. Let's say that we have a times x to the n. For this to be in scientific notation, a has to be a number that is at least 1, but it has to be less than 10. And this should not be x to the n, it should be 10 to the n. And n needs to be an integer. that's a positive or negative whole number. So as an example, I'm going to write down some numbers and you tell me its scientific notation. 2 times 10 to the 5th, is it or isn't it? 0.2 times 10 to the negative 3rd, is it or isn't it? 4.12367 times 10. And let's go with negative 1.4 times 10 to the 8th. This first one is scientific notation. The 2 is at least 1, but less than 10. It's being multiplied by 10 to an exponent, and the exponent is an integer. The second one is not scientific notation because this 0.2 is not at least 1, it's less than it. This third one is scientific notation. The number at the beginning is at least 1, it's less than 10. Multiplied by 10 to an exponent. The exponent is not written there, but it's a 1. The fourth one is not scientific notation because it is negative, and it needs to be positive to be in scientific notation. Alright, let's do an example. Which of the following is equivalent to this ungodly number? Well, you'll notice first of all this is 3.64. These are all 3.64. Nothing to look at there. The only thing that's different with these answers are the exponents. If your original number is bigger than 1, you're going to have a positive exponent. If your original number is less than 1, you're going to have a negative exponent. This original number is bigger than 1, our exponents cannot be negative. These are really tiny numbers. So, to figure out what this is in scientific notation, you take your decimal point and you count how many times you move it to get to the 3.64. 1, 2, 3, 4, 5, 6, 7, 8 times. Therefore, this is 3.64 times 10 to the 8th. Number 2, the distance from our solar system to the nearest star, can't even pronounce that, is 2.49 times 10 to the 13th miles. The distance from our solar system to the next closest star, alpha something, is 2.56 times 10 to the 13th miles. How much closer to our solar system is the closer star? Well, to do this problem, we're going to have to take 2.56 times 10 to the 13th minus 2.49 times 10 to the 13th. Subtract those. Now you can treat the 10 to the 13th kind of like a variable because we're multiplying that. You can factor out that, since it's in both terms, and you're left with 2.56 minus 2.49. If you subtract those, you're going to get 0.07. Now the problem is 0.07 times 10 to the third is not scientific notation. So we're going to have to move this decimal place 2 places to the right to get a whole number 7, 7.0, or the answers just say 7. When we do that, this 10 to the third is going to get smaller by 2 movements. So 3 minus 2 is 1, so it's going to be 7 times 10. I'm sorry, this was supposed to be an exponent of 13. 13 minus 2 is 11. So we get 7 times 10 to the 11th. Another way to look at this, people get confused. If I move left, am I adding the numbers to the exponent? If I move right, am I subtracting? Which is it? It does get confusing. So here's how I actually do it in my mind, because I get confused also. So let's just leave the 10 to the 13th. Just focus on this. .07 means 7 hundredths, which means 7 times 1 over 100. 1 over 100 is the same thing as 100 to the negative 1, which is the same thing as 10 to the negative 2. Maybe I went too deep into the rabbit hole there. Now at this point you're multiplying the same base, add the exponents, and you get 10 to the 11th. Alright, come and see me at my desk if that is just overload, and I will be happy to try to explain that better. Excluded values. These are numbers that you cannot use into the problem because it makes the problem undefined. So mainly for us it's going to happen in two different locations. You don't want your denominator to equal 0. My handwriting is taking a turn for the worst. Your denominator cannot be 0. So for example, if we had a problem like 3x over x minus 4, our excluded values would be x equals 4. X can't be equal to 4. Because if you put a 4 in here for x, 4 minus 4 is 0. Can't happen. Also, excluded values happen if you want to use just real numbers. You don't want your evened root radicand. I'll explain what that means in a second. You want that to be bigger than 0. So you don't want it to be less than 0. So even root means that this is either a second root or a fourth root or a sixth root or an eighth root. The radicand is what's on the inside. If you take an even root of a negative number, you get an imaginary answer. So we want the answers in here to be positive. Let's look at the first example. For what values of x is this undefined? Well, these things undefined happen in two places once again. Even root radicals, which we don't have any, and fractions, which we do. Take your denominator and you set it equal to 0. You get x by itself, and this tells you what x can't be. X cannot be 0. If you're still not sure when you get to the end, maybe there's more, maybe I'm missing something, take these numbers and plug them into the problem. If it ends up being undefined in your calculator, then that means it's an excluded value. Imaginary numbers. Here's the definition of an imaginary number. The square root of negative 1 is defined as I. That's it. Square root of negative 1 is defined as I. Let's look at an example. Which of one of these following is equivalent to square root of negative 4 plus square root of negative 9? So let me show you. I'm going to write it down here to get more room. Well, negative 4 is equivalent to negative 1 times 4. Negative 9 is equivalent to negative 1 times 9. The square root of negative 1, we just said, was I. Square root of 4, what number times itself is 4? That answer is 2. Square root of negative 1 over here again is I, and the square root of 9 is 3. So this is 2i plus 3i. It means you got 5 i's. So the answer is H. Next one, what is equivalent we got square root of negative 9 times square root of negative 9. So let's see what we can do with this. If we were to rewrite this so that we have negative 1 times 9 times negative 1 times 9. The square root of negative 1 is I. Square root of 9 is 3. Square root of negative 1 is still I. Square root of 9 is still 3. This is going to give us 3 times 3, which is 9, times I squared. Now what is I squared? Don't necessarily have to memorize it. You have to memorize this fact, that the square root of negative 1 is I. So I'm going to use that fact to tell you what I squared is. If I take this equation and I square both sides, on the right I get I squared. On the left, if you square a square root, they cancel and you're left with negative 1. Therefore this is 9 times negative 1, which is negative 9. So the answer to this is A, negative 9. Number 3, if x is a positive integer, which one of the following could be the value of I to the 2x? Well, how about we do this? How about we put some numbers in for x to see if we can get one of these answers? Let's say that x is 1. That's going to be I to the 2 times 1, which is I squared, which we just said is negative 1. So we didn't get any of the answers there. Let's try x equals 2 and see what we get. It's going to be I to the 2 times 2, which is I to the 4th. I to the 4th is the same thing as I squared times I squared, which is negative 1 times negative 1, which is 1. Hey, we got this for an answer. There's no sense in continuing with this, because which one of the following could be the value of I to the 2x? Well, the answer could be 1. Moving on. Which of the following is an imaginary number? This is a positive square root, so it's not imaginary. Positive square root, not imaginary. The negative cubed root of 2, not imaginary. Not imaginary. D is imaginary. It's imaginary because I shouldn't have circled those. Whoops. Sorry about that. User error. I should not have circled those because that implies the correct answer. Let me just mark those through. So 4 is the correct answer because the even root of a negative number is imaginary. Complex numbers. Complex numbers is when you combine all the real numbers and all the imaginary numbers together. So like, here's a complex number. I said all of them together. I just mean a term that has both. So like 3 plus 2i. That's a complex number. This is a real number, and this is imaginary. So let's see. Let's look at this example. We got 14i minus 3 minus 5 plus 9i. If we distribute the minus to get rid of the parentheses, we're going to get 14i minus 3 minus 5 minus 9i. If you combine like terms, minus 3 and a minus 5 is negative 8. Plus 14i and a minus 9i is going to give us a plus 5i. So the answer is negative 8 plus 5i. Essentially, you're just combining like terms. Imaginary numbers are like terms, real numbers are like terms. If 3 times 6x minus I equals 36 plus yi, which of the following are values of x, y? This seems really complicated. Truth of the matter, it is not. Let's first simplify this to get rid of our parentheses, and then we'll try to figure out how to do this problem. If we distribute the 3, we're going to get 18x minus 3i. And we get equals 36 plus yi. What you do next is you set the real parts equal to each other, and you set the imaginary parts equal to each other. So we're going to set 18x equal to 36. We're going to set negative 3i equal to yi. 18x equals 36. And we're going to set negative 3i equal to yi. So, since I'm here in blue, we're trying to get y by itself. We're going to divide both sides by I. Anything divided by itself is 1, so y is negative 3. Our red equation, if you divide both sides by 18, you get x is 2. So we're looking for the ordered pair 2, negative 3. Boom, C. Oh, we're getting close. Number 3 here, we're going to use the distributed property, the FOIL method, whatever you want to call it. You can call it lots of things. Just call it straight up multiplication if you want. We are going to multiply the 2 times the 3 and get 6. 2 times the minus 5i and get negative 10i. 4i times 3 is 12i. 4i times the minus 5i is negative 20i squared. So that's going to be 6 and then a 10i plus, I subtract 10i plus a 12i is a plus 2i. And then an I squared over here is negative 1. So that means this is 6 plus 2i plus 20, which is 26 plus 2i, which is answer H. One more. Yay! Which of one of the following expressions is equivalent to this hot mess? Well, it's not really proper to have imaginary numbers on the bottom of a fraction. Why? I don't know. This just isn't. To fix it so that it's not down there, you want to multiply the top and bottom of the fraction by the conjugate of the bottom. Conjugate means it's the same complex number, but it's a plus sign. It's the opposite sign instead of what's there, I should say. So 5 minus 2i and 5 plus 2i, those are called conjugates. I don't know how to spell it, so I'll just write it sloppy and then erase it. We're going to multiply the conjugate of the denominator times the top and bottom. Using the distributive property, we're going to have 4 times 5, which is 20. 4 times 2i, which is 8i. 3i times 5 is 15i. 3i times 2i is going to be 6i squared. Our denominator, we got 5 times 5, which is 25. 5 times 2i is plus 10i. And then we have negative 2i and 5 is minus 10i. Negative 2i and a plus 2i is a negative 4i squared. When you multiply two conjugates, the middle two terms will always be the same with opposite signs, so they're always going to cancel. In our numerator, we got 20, combining like terms, plus 23i plus 6 times negative 1, I squared is negative 1. Our denominator, we got 25 minus 4 times negative 1, because I squared is negative 1. We're getting close. So this here is a negative 6. Negative 6 plus 20 is 14. Plus 23i is not like terms. 25 minus a 4 times negative 1 is like 25 plus 4, which is 29. So we're looking here at answer B, 14 plus 23i over 29. Do yourself a solid. Do exercise set 4. Take your time. Also, don't waste time. Do your best. Peace out.